Okay, so before we get started, I want to remind you that this is the last week that we'll be meeting for labs. What that means for you is that starting 1 week from today, starting next Monday, we'll go back to our normal Monday, Wednesday, Friday schedule. So you'll turn in Lab 5 on Monday. It'll be due midnight on Monday, but we will have a lecture on Monday, and then from now to the rest of the semester, we'll meet Monday, Wednesday, Friday. We will finish the semester early, probably maybe about a week early. We'll see as we get closer to the end. Today, what I want to do is I'll talk about program control instructions, and then I want to make sure everybody was able to submit their quiz 7, and then I'll see if you have any general questions, and then that'll be it for today. So the topic of discussion is program control, and what that means is that there are ways in any kind of computer programming language, but specifically when you're programming a PLC, you can control what we call the program flow, and that's what we mean by program control. And there's several ways that you can control the flow of a program. We'll talk about three main ways that we can use with the PLC, but there's others. So what you see on your screen right now is a typical program control instruction set for a PLC. And most PLCs will have these instructions, and we're only going to talk about a few of these. So we'll go into the lecture now, and the first thing I want to talk about is something called the master control reset. So we'll talk about that, and let me size this. So as I said before, program control allows you to control or to manipulate or adjust the flow of the program. And this is done in different ways depending on the instruction we're talking about. And I'll give you an example of 3 different ways or different instructions that you can use to control the flow of program as you go from one rung to another. The main ones that we're going to look at today, one called the MCR, Master Control Reset. There's the jump instructions, and then there's my favorite one is called the subroutine. So we'll look at these. 2 of these instructions, 2 of the 3, the MCR and the jump, JMP, those are called override instructions because they allow you to basically skip over certain portions of your program. And so override instructions are kind of useful because, well, for several reasons. They have certain benefits or advantages. You can basically, kind of like the function chart programming we talked about the other week, you can implement or you can skip over or activate certain parts of the program and skip over other parts, which kind of makes the program a little bit more efficient. So because you don't have to run all parts of the program, it increases the efficiency. We'll talk about how program flow and these instructions can make the program more flexible. I'll give you an example of that. So we want to learn how to use the override instructions, which would be the master control reset and jump. So we'll deal with those first. So when we talk about skipping over portions of the program, you got to have a way of letting the microprocessor know which part of the program to skip over. And this is done in various ways. Most often what they do is there's a way for you to identify an area or zone in the program, and you can get the processor to skip over that zone once that zone is identified. And so there's different ways to specify the zone, and I'll show you a couple of examples here in just a second of ways you can specify the zone. Before we get into that, though, I want you to look at the diagram I have here. This is a schematic of a relay control circuit. And if you look at this ladder, this hardwired ladder, you'll recognize a couple things here. The first thing you should recognize is on the first rung, you got this part right here. That's your latch circuit, your seal-in circuit. And they call this, there's a master start and the master stop switch. This master start and master stop switch. So look at how this control circuit, how it works. If you notice, you'll see something here on this schematic that you've never seen before. You've never ever seen these vertical contacts. There's two vertical contacts, one here and one right here, and they have the address of this coil right here, the MCR. So basically the way this works is that when you press this button right here, that start switch, you activate this coil, the MCR. There's a latching, a seal-in contact here. So when you release this button, then this coil is latched on. And when this coil is on, basically you connect. Now remember, this L1 and L2 represents your power. These are your power, we'll call them power lines, line 1 and line 2. And basically if we think of current flow and not logic flow, we just think of current flow for right now. Current's going to flow this way from it's going to flow from left to right. It's going to flow from L1 to L2. Well, in order for that to happen, these vertical contacts, they have to be closed. And so what this master start, master stop does is, if this rung is true, that first rung, if it's true, then these vertical contacts are closed, and basically the ladder will operate normally. It'll operate normally. If you hit this stop button right here, it'll open up these contacts, and basically it's like a main circuit breaker or main fuse. It'll cut power, and the rung will no longer operate. And so this master start, master stop, we like to be able to implement that in the PLC program, but we have one problem. The problem is there's no way to implement these vertical contacts. There's no way to duplicate these vertical contacts in relay ladder logic. There's no way to do it in the PLC. So what they do is they have these commands that will allow us to define what we call a zone. And this is an example of what I mean by a zone. This command right here, we have two commands here, two instructions, and these are output instructions. This is the MCR instruction. And I said we have two. There's really one instruction. There's an MCR. There's an MCR here, and there's an MCR here. But each of these instructions define a zone. They basically define a zone that we can control any instructions between the first MCR and the second MCR. Now, the first MCR, we refer to that as the start fence, and the second MCR, we call that the end fence. So think of this as the start of the region that we want to skip over or control, and this is the end of the region that we want to skip over or control. So we got the start fence and the end fence. And the way this works is, if this is true, notice that this MCR on the first rung is conditional. It has an examine if closed there, and it's mapped to this button right here. The one on the bottom is not conditional. It's true all the time. So the way this works is, as long as this is true, as long as that first rung is true, then anything between the start fence and the end fence is going to run. It's going to operate as if the MCR instruction wasn't there. It's going to run as normal. But if this first rung is false, then what happens is it deactivates everything between the start fence and the end fence. Now, it's important that you realize when we say deactivate, depending on whether you have non-retentive or retentive instructions, they're going to behave differently. So let me kind of go to the next PowerPoint, and we'll point this out. So we got the end MCR. It's always true because it's not conditional. But the one I was referring to is this one. When that first rung, the one containing the MCR, the conditional MCR at the top, when this one right here is false, then it will deactivate outputs. All the outputs are deactivated. But you got to pay attention to whether you have a retentive output or non-retentive output. All non-retentive outputs will go false. If you have a retentive output, it's going to keep, remember retentive, like a retentive, we talked about a retentive counter, right? A retentive timer. We talked about a retentive timer. And a retentive timer, if you stop the timing, it'll start at where it left off. So if it counted out to 11 seconds and you stopped it and you restarted the count, it wouldn't reset back to 0. it'll start at 11 to keep on counting. Well, if you put that retentive timer or any retentive device in the MCR zone between the start and the end fence, then it's going to retain that count or that state. And so typically, you don't want to do that. Normally, you don't want to replace, you don't want to place retentive instructions in the MCR zone. Now, it's not to say that you can't do it. If you know what you're doing and you really intend to do that, then it's okay to do it. But most of the time, when you restart a program, a PLC program or some kind of process, you don't want things to come on or to start in the on position. And that's the reason for saying that typically you don't put retentive devices in the MCR zone. So, if you ever have to do this, make sure that if you have some retentive device, latch, timer, counter, if it's retentive, and you have it in that between that start and end fence in that zone, make sure that you intend to do that. So the MCR is the first instruction, and it's pretty simple to use. Again, you have the same instruction that you used twice. The first one defines the start of the MCR region. The last one defines the end of the MCR region or zone. We refer to this as the start fence and the end fence. And just remember that the start fence is conditional because you got to be able to say when you want the zone to be active or not active. And the end fence is always non-conditional. It's always true when you want to get out of the zone or disable it. You need to have the last MCR instruction to be always true. So this slide right here, if you printed out your 3 slides to a printout, you probably want to mark this one, just kind of an overview of how that particular instruction works. And I won't read it to you, but you can kind of read this yourself. So mark this slide, and just as you review the operation and make sure you understand how the MCR works. So that is the first instruction, the first of the override instructions. Anybody have any question or general questions over the MCR instruction? It's pretty simple, and you can play around with it in your simulator. We can talk about it in the PowerPoints, but really to see how it functions, you need to kind of mess around with it in your simulation software to get an understanding how it works. But I think that one is pretty straightforward. So anybody have any questions over MCR? Well, then we'll go to the next 2. So the next one I want to talk about is called the jump instruction. And this PowerPoint actually deals with 2 of the 3. It deals with the jump, which is, again, is an override. It's the second of the 2 override instructions that we were going to talk about. But then the last one is a subroutine, and that's one of my favorites, and we'll talk about that here in just a second. So let's talk about the jump. And in a lot of programming languages, there's ways for you to skip over and move around in the program. One of I won't say the first, but one of the first programming languages that was designed for lay people was called BASIC programming. And in that particular language, they had a statement called the go-to statement. I don't know if any of you guys are familiar with BASIC. It's not used much anymore, but it was used back in the day, right around when a lot of people started getting personal computers, the big old desktops back in the day. And so BASIC was a way that you can get beginners. As a matter of fact, the B in BASIC stands for beginners. I forget what the acronym is. Beginners, all-purpose instruction code or something like that. But in that programming language, they had something called a go-to statement. And in that particular language, what happens is each line of the program, you had to start it with a line number. So you started with line number 0, the number 1. Each instruction had a line number. And that go-to statement, it could be on the line by itself, and you can say go to line number, say 40. And if you're on line number 3, it'll skip everything after 3 between 3 and 40, and it'll start actually number 40. It'll go to whatever line you had after the go to instruction. Now that was a way to to jump instructions, and that is similar to the way this jump instruction works in the PLC. Now, I have to admit, I'm not a big fan of this instruction. I think I have experience in just kind of basic programming, C programming and other languages. And any good programmer is going to tell you it's not a good idea to jump around, especially when you can jump backwards and forwards in the program. So I'm not a big fan of this, but it is useful. I mean, you can use it as a patch. And as we go through this PowerPoint, there's some advantages that will be brought out that you can use this instruction for. But I would say, just kind of as a rule of thumb, you don't want to use this instruction too often in the program. If you have a really long PLC program for a really complicated industrial process or control process, you don't want to use this a lot. You don't want to jump around a lot. It'll make your program hard to follow and hard to debug if you have errors in the program. But having said that, let's kind of go into this. This instruction does have some advantages. You can reduce the scan time, because if you jump over portions of the program, you don't have to scan the portions that you jump over. So one advantage is you can reduce scan time. Another advantage is you can actually have the PLC hold more than one program in one ladder, and you can jump to any program you want in a really long ladder. So you can kind of use this to make your programming more modular, which is always nice, because it's nice to have structure to any kind of program. So in theory, you can do this. I've never done it before, but you can have several programs in one long run and just jump to the program that you want to use when you want to use it. So that's another advantage. So and then the last one here that was mentioned here is that you can program it to jump over or jump to or jump over a certain parts or portions of the program if some kind of error, condition, or fault occurs. So there are certain advantages using jump, but as I said, you just don't want to use it a whole lot. If you have a really long program, you can run into trouble if you use a whole lot of jumps. If you're jumping all around and back and forth in your ladder, it's going to make it hard to follow. But how does the jump instruction work? Well, actually, it's used in conjunction with two tags. You have a jump command and a destination instruction or command. And so basically, and this is just kind of a generic program here. So basically, the way your scan pattern works is your processor is going to scan your program from left to right. So you'll scan here starting with the first rung from left to right, and then it'll scan the next rung from left to right. But when you get down to this jump, if this is true, now this first jump instruction is conditional. So if this rung right here is true, it's going to skip over all of these rungs and jump down to the destination. It's going to jump down, and it'll actually start. Everything after this, it'll run. It'll skip the region in between the jump and the destination. So in order for this to work, you got to have this jump instruction, and then you got to have this destination instruction. But in order for this to work, you got to have a way of mapping this jump to that particular destination. The reason is you can use more than one jump instruction in a program. And so the way you do that is by using the label. So here's how this would look in your program. You would have, and remember, I'm not showing the rungs in between that you're skipping over, but you'd have your first rung here, and notice that this rung is conditional. So if this is true, then you'll activate this jump instruction. And so what will happen is this jump instruction, this number right here is the number of the label it's going to jump to. And so the label down here is label 01. So when this instruction is true, it's going to skip over all these instructions in between. It's going to jump down here to label 01, and it's going to run everything after label 01. And so you can actually, if you wanted to, you can have more than one of these jumps in a program. You can have, say we can jump from this position right here, or I can jump from this position in the program right here. There's no reason why you can't have more than one to jump to label 20 from more than one location. But you can kind of see now what I'm talking about, that if you have a lot of these in the program and you have to troubleshoot the program, it's going to be really hard because you got to actually follow these jumps around as you go through. So as I said, there's better ways to do this. And probably one of the best ways is using something called the subroutine. So I'm not a fan of the jump instruction. I do encourage you to play around with it in your simulation software. But I think the subroutine is best for almost any application that you're going to have where you want to control program flow. And most computer languages have some kind of way of writing a subroutine. Let me define what a subroutine is. Basically, a subroutine is just a small mini program that'll run by itself. It's a standalone program that'll run by itself. And so in a lot of programming languages, what they'll do is they'll just write a bunch of subroutines to do certain things. And then in the main program, all the main program does is call the subroutines. And so an example, I'll show you here in just a second, but in order to actually use this, there's actually 3 instructions you got to use to create and to use a subroutine correctly. Now I want you to pay particular attention to this because in your lab 5, I don't know if you know this, is already posted, it's up. And in that lab, you're going to work with these instructions. And the main one is going to be the subroutine. You'll get some practice using the other 2, but the main one to focus is using the subroutine. And then soon, not too long from now, we'll give you the next exam number 2. And remember what I said about exams. There's actually 2 written exams, one of which you've already had. Exam 1, you've already had that. The final exam, exam 4, are written exams. But exam 2 is an actual program you'll do, and exam 3 is some research that you'll do. So there's only really 2 written exams. But in exam 2, not exam 2, in exam 2, you'll have a chance. Well, the lab that you have assigned this week, you'll use the subroutine. In the lab, in exam 2, I don't think you're required to use a subroutine, but that might be a place for you to actually to use it. Again, I don't think it's required in exam 2, but it can make things a little easier if you use it, a little neater for you. So let me talk a little bit about this subroutine. I mentioned that it takes 3 instructions to use the subroutine. The first one, the JSR, the jump to subroutine. So this is the one that's going to be in your main program. When you create a subroutine, you actually have 2 programs. You have the main program, the one that you're used to creating, but then you have the actual subroutine, which is a separate program. And so this jump to subroutine is the instruction that's actually in the main program, and you have a little label that tells you which subroutine to jump to, because in the PLC, in theory, you can have as many subroutines as you want. The only limit is the memory. Now, in your simulation software, you can have a certain number. It's fixed. Obviously, it's fixed. But in an actual PLC, there's no limit. It's only limited by your memory. And so you can jump to any subroutine you want. And so to do that, you have basically a file number right here. Each subroutine will be in the file number. It'll be tagged. So you have the jump to subroutine, this is in your main ladder. And then in the actual subroutine, you'll have these other 2 instructions. This defines the file as a subroutine. And this is the return instruction, which when you get to the end of the subroutine, then this return instruction will take you back to the original program. So here's a definition of each of those. JSR causes the processor to jump to the targeted subroutine file. And here at the bottom, it mentions where those files are in your simulation software. Now, in this PowerPoint, I actually walk you through step by step building a subroutine. You've probably seen these when you were in your simulator. If you X'd out of the I/O simulation and you see the folders behind the I/O simulator, and these are some of the folders that you keep your data tables in. You would have seen your subroutine files around that area. But again, I'll walk you through in this PowerPoint step by step how to build a subroutine, and I'll show you where these subroutine files are. So you have, I would say mark this slide because this kind of defines what those instructions are. But you got the jump to subroutine. It tells you what it does here. It causes the processor to jump to the targeted file where you put the subroutine. And these are the actual subroutine labels that identifies that particular file as a subroutine. And then the return is always the last statement in the subroutine. When it hits that particular instruction, it'll jump back to the main ladder. And so kind of in a schematic kind of a way, here's how it works. Over here, here's the main program that you write, just like you've been doing all semester. You write that program. But then what you can do is create another little subroutine, another little mini program, not in the same, it actually lives in a different folder. It's not in the main, it's not kept in the same file or folder that the main rung is kept. It's kept in an area called the subroutine files. And so you'll write it in the way that you'll run the program, and notice that this jump to subroutine is conditional. So it's mapped to some sensor, some switch out in the field. And as you run through your program, if this rung right here, if this rung is true, then what will happen is this jump to subroutine, this JSR is true, it'll actually jump out of your main program over to your subroutine. It'll run whatever you have in that subroutine file. So it'll run the subroutine, it'll run all these rungs, and when it gets to this jump to subroutine instruction, or this return command, it'll come back and it'll come to the rung after the JSR instruction in the main program. So just kind of know this, the flow here, that you're flowing through your normal logic. If this rung is true, you jump out to a new file, your subroutine file, you'll run all these instructions. When you get to this return, it'll come back to the rung after the JSR command or instruction in your main rung. Now, I'm not 100% certain about this, but I'm like 95% certain that this RET, this return instruction, if you leave that out, I think it'll still work. You can practice just to, I mean, you can check it out to check this out. But I'm pretty sure if you leave this out, then by default, it'll automatically go back to the main rung. When it gets to the last rung over in the subroutine, it'll go back, it'll automatically start with the rung after the JSR. Again, check it out in your simulator, but I'm 95% sure that you can omit that. It's not good programming practice, but I don't think you'll run into any trouble if you omit the return. So what you got to know is, how do you set up a subroutine? And as I said, since this is actually part of your lab, and you're not required to use it in exam 2, which is going to be a program, but if you want to have a place to use it, that would be where you use it. So I'll walk you through step by step how to create a program, and I'll show you that in just a second. Here's an example of a program that uses a subroutine. Now you got to be careful here, because what I tried to do was put 2 programs on one PowerPoint slide. Be aware there's actually 2 programs here, and they do not live in the same space inside your PLC. Your main ladder lives in one file, and the subroutine is in a totally different file. So it looks like they're together here on this PowerPoint, but they are not. So what you see right here at the top, that's your main ladder that you're writing. So this is the main ladder. Now, it just so happened we started this main ladder with the jump to subroutine, but you really wouldn't do that. I mean, you have rungs above this. There's rungs up here, and you will eventually get to this rung, which is mapped to a sensor in the field. So when that sensor makes this examine if closed true, then it'll activate the jump to subroutine. What that means is all these rungs after this instructions are skipped, and you'll actually jump to a completely different part of memory. Over here you see it says subroutine, which is file number 3. I believe it's file number 3 in your simulation software. You'll jump out of file 2, which is holding your main program, and you'll jump to file 3, and in file 3 is a program that you've written, another entirely different rung that you've written. That's your subroutine. And that subroutine, you'll run it, and then it'll go through these rungs, and when it gets down to this return, it'll go back to the main program, but just remember, it'll start in the rung after the JSR. So it's going to start right here when you jump back to the subroutine. So the way this works is inside your simulation software, you'll actually click on file 3. You'll double click on file 3, and when you double click on file 3, it'll open up a window that looks just like your normal window where your edit window where you write the rungs. It'll open up another window. You can put another ladder there, and that's going to be your subroutine. And you can actually jump to and out of that file at will when you want to. Now, one main thing when you're using, here they call it a subroutine. In other programming languages, they call it a function or an event. There's a lot of different names for these mini programs. When you write a subroutine, you don't want your subroutine to be a whole nother program. Well, it's a separate program, but what I really mean is, at most, you want a subroutine to do 1 or 2 different things. You don't want it to do a whole bunch of stuff. You want to do like 1 or 2 different things and then jump back to the original program. And so it is really possible to have a subroutine for almost every action in your PLC program and just use your main rung just to call the subroutines to get them to do what they want, what you want them to do. That is a method of programming, and it's a pretty, if you ever heard of object-oriented programming or procedural programming, it's a method that programmers use by just calling subroutines, and it's a really, really good way to program because basically then everything's modular. It makes things a lot easier to, number one, to troubleshoot, and number two, more importantly, you can make changes in the program. And since each program, each subroutine is its own mini program that works regardless of what's around it, you can make changes in that subroutine and you don't have to worry about it affecting something else in the program. And with programmers, that's a big thing. It's big. The other thing that's big about it, that's a really good advantage of using subroutines is once you get a subroutine that works, that's perfect in your eyes, you can use that subroutine in other programs. So, and I think I mentioned this before earlier in the semester, but people in computer science or computer programming, there's something called reuse. That when you develop a piece of code or software, you can use it in other programs or other pieces of software. And so with a subroutine, you can actually do that. Once you have a subroutine that works, if you can use it in other programs, you can just call that subroutine. You don't have to reinvent the wheel. So the rest of this, there's a lot of slides here, but the rest of this, I'll just kind of click on them so you can see them. I'm not going to talk about them. But what I did is I took time to go through and step by step show you how to create a subroutine. And what I would recommend doing is that you open up your computer and maybe print these slides out and just kind of step by step follow these slides and walk through creating a subroutine. And I would do that before you do the lab, for this week, or at least the part of the lab where you have to do the subroutine. Just kind of use this PowerPoint as a guide, create a subroutine like I do here in the slides, and then do the lab. And I think you'll find the lab to be pretty simple this week if you do that. So let me click on some of these so you can see what I'm talking about. So I actually take you through step by step, and I label these for you. So you can go through step by step, and if you follow these step by step, you'll end up with the subroutine. Right here you've probably seen this when you click off of your I/O simulator, you've probably seen these files and maybe you never really paid any attention to them. But right here you can see in your simulation software, you have file 3, 4, file 3 to 9. Those are all subroutine files. So literally you just double click on one of these and it opens up another window and you can put your subroutine ladder in that file. So again, I won't go through all of this, but just kind of click through these. If you click through these, it walks you through creating a subroutine, and it'll be crystal clear. You won't have any trouble creating your subroutine at all if you follow this first. And again, I would recommend following this first, and then at that point, do the lab, and I think you'll find the lab to be pretty easy if you do it that way. So anybody have any questions over the jump instruction or the subroutine instruction? Any questions over those two instructions? Okay, well then let me move to the quiz. Now, I emailed you a copy of quiz 7. I don't know when I emailed it, but you should have received that in your email. And then what you were to do is to print that out, um, fill it out, and then the way I decided to have you submit it was to email it to me. When you email it, you need to make sure you put UC student in the subject heading. I have a filter set up in my email. I get so many emails that if it goes somewhere else, I might not find it. So I know several people did that, and if you turn that quiz 7 in as of yesterday, I don't know what time, but everything should be graded and on your grade. Now I sent out a list of people for whom I didn't have a quiz for. So I'm wondering if there's anybody that sent me a quiz that didn't get a grade, and if you did, I think I was going to have you resubmit it. But if you're not showing a grade, then you can let me know, and I'll check. So let me know if you guys, did everybody get a grade? If you submitted quiz 7, did everybody that submitted quiz 7 get a grade for quiz 7? Is there anyone that didn't get a grade?
I submitted the quiz and I didn't get a grade.
Okay, wait a minute. Okay, who's talking right now?
Luke Giacomo.
Luke, what's your last name?
D-I, capital G-I-A-C-O-M-O, Giacomo.
Okay. Okay, so I'll take a look at yours, Luke, and I'll text you. I'll check to make sure I got it. You did put UC student in your subject heading?
Yes, I sent it to your Hotmail account, and I put UC student in the subject.
Okay, Luke. So what I'll do right after class, I'll check, and if there's any issues, I'll send you a text on your cell phone.
Okay.
Okay, and wait a minute. Somebody else just sent me. Okay, now if you sent it after I sent that message on Canvas, I haven't graded those yet. So if you submitted it, you want to check that list. If your name is in that list, I think I stopped grading last night at some point, but I'll go through and let me see who's sending me messages now. Hold on a second. So I'm saying, okay, Will says he doesn't have a grade. So Will, I'll check yours. Will M. And then Brent. Okay, Brent says he doesn't have it. So I'll check yours. Hall. And then Daniel says you emailed it last week, and I don't have that. So let me, Daniel Hagan. Okay, so I have Luke, Will, Brent, and Daniel. Is there anyone else that think they submitted the quiz and didn't get a grade for it? Again, if you just submitted it after I sent that list out, I haven't graded those yet, but okay, we got okay, yeah, Kenny, you'll be okay. I'll tell you what, Kenny, I'm going to go ahead and write your name down here. Will Kenny, I'll write your name down, and I'll just double check that. So what I'm going to do is, Orion, you sent yours last week too. Okay. Okay. So what I have Luke, Will, Brent, Daniel, the other Will Kenny, and Ryan. And Matt, you sent it this morning. Okay, I'll check that. So I'll check all of these. I'm writing your names down. I'll check, and then if there's any issues with me receiving those, I'll since you guys sent me attendance, I'll contact you by your I'll text you a message. But at about 2:05, I'll go in and I'll take a look at these. Okay, so that's quiz 7. Now let's talk about the lab 4. Anybody have any issues or questions about lab 4? Okay, well, I'm in my office, and my number is on the syllabus. I'll be on my phone, available on, if you need to call me, I'll be after 2 o'clock, I'll be available. And I'll also be available to receive a text. So if you think of anything, lab 4 is due tonight at midnight. Lab 5 is already out there and available. So go ahead and take a look at that. If you have any questions, let me know. I think you'll find that to be pretty straightforward and pretty easy. I don't think you have any issues with it. And then somebody mentioned something about homework that was active and shouldn't be. I'll take care of that. And other than that, guys, that's all I have for today. You guys have a great rest of the day. Again, you can call my office phone or send me a text if you have other questions. And other than that, I'll see you 1 week from today. Just remember, next Monday, we go back to our meeting 3 times a week, and we'll do that for the rest of the semester. See you guys later.
So is the homework 6 supposed to be due a week from today then?
Let me check, and I'll let you know. It shouldn't have been activated until next week.
Okay.
Typically, I give you a week to do it, so it's probably the week after next. But
Okay.
let me just get there and see what's going on. It won't be due this week, so you don't have to worry about it right now. Just focus on the lab right now.
Cool. All right. Thanks.
Okay, see you guys later.
Professor, before you go,
Yeah.
the lab 5 says it has not been like
Wait a
activated.
minute. Hold on. Well, I can't hear you. You're some kind of echo. I don't know. Something going on with your audio, man. Try it again. I can't hear anything you're saying.
Can you hear me now?
It's a little bit better now. Go ask your question again.
So lab 5, it's like the submission part's there, but the actual lab itself is not activated.
Oh, okay. Thank you. I know what you're saying. Thank you. I got you. I'll do that. I tell you, this canvas is something else for me. I'll fix that here in just about 5 minutes. Thank you for letting me know that.
All right, thank you.
Thank you. You guys, see you later.